The diagram shows part of the curve y equals x minus 1 to the power of minus 2 plus 2 and the lines x equals 1 and x equals 3. The point A on the curve has coordinates 2, 3. The normal to the curve at A crosses the line x equals 1 at B. Show that the normal AB has equation y equals a half x plus 2. So a normal is perpendicular to the curve at the point. So it will be perpendicular to the curve at the point 2, 3. A normal is a straight line, so all straight lines are in the form y equals mx plus c. So the first step is to find the gradient. Since it's perpendicular to the curve at that point, we can find the gradient of the curve at that point by first differentiating or finding dy over dx. So dy over dx is equal to drop the power x minus 1 to the power multiplied by the differentiation of the bracket, which is 1 in this case. And the differentiation of 2 is just 0. So dy over dx is equal to minus 2 x minus 1 to the power of minus 3. We want the gradient at the point 2, 3. So dy over dx at 2, 3, you can find by substituting x with 2. So that gives minus 2. So the gradient of the curve at that point is minus 2. But the normal is perpendicular to the curve at that point. So the gradient of the normal has to be minus 1 divided by minus 2, which is a half. So we know that for the straight line y equals mx plus c, m must be a half. So the straight line must be y equals a half x plus c. We also know that it must pass through the point 2, 3. This means that when x equals 2, y equals 3. So we can substitute that in to find the value of c. So that's 3 equals a half times 2 plus c, and we can use this to solve for c. So if we do that, c is equal to 2. Therefore, the equation of the normal is y equals a half x plus 2, which is what it wants you to prove it to be. Okay, so that's done. Part 2. Find, showing all necessary working, the volume of the revolution obtained when the shaded region is rotated through 360 degrees about the x-axis. So this is the diagram of the graph. And that is the tangent, the normal over there. To find the volume of a solid rotated about an axis, we have a formula for that, which is not given in the formula sheet, so you have to remember this. So we're rotating it around the x-axis. Therefore, the volume is equal to pi integral of y squared dx. But we need to divide this diagram or this region into two parts, because for one of the parts, the line that separates the shaded region to the not shaded region is the line y equals a half x plus 2. But for the other one, it's the curve. So we have the first region over here, and the second region that we would need to use the equation y equals x minus 1 to the power of minus 2 plus 2. That means we need to separate the integral into two parts. So the first part would be pi integral from 1 to 2 of the normal squared plus pi integral from 2 to 3 of the curve squared. So to find the volume, we need to work out this integration. So we can separate it into two parts. So for the first part, first we can expand the brackets to make it simpler. So after expanding the brackets, each term you can integrate each term like you normally do. So add 1 to the power and then divide it by that power. So you can do that to each term in the integral. And integral from 1 to 2 means you're going to substitute 2 into the expression and subtract it with the substitution of 1. So if you do that, that equals 91 pi over 12. So the first part, or the purple part of the solid, would be 91 pi over 12. Now we need to work out the second part. So first, if we expand the brackets, because it's a squared, we should get this. So it turns into the integral of x minus 1 to the power of minus 4 plus 4x minus 1 to the power of minus 2 plus 4 dx. I'm going to separate that into two integrals, like this. For the first part, it's difficult to integrate it. So we can integrate it by substituting. We're going to substitute u equals x minus 1 for the first part. If u equals x minus 1, du over dx is equal to 1, meaning du equals dx. So if we use that substitution, it turns the integral into pi integral from 2 to 3 of u to the power of minus 4 plus 4u to the power of minus 2 du, which is in a format that you can integrate. And the second part is still the same. So now that we're integrating du, not dx. For x, it's 2 to 3. So if you're integrating u, you also need to change the region to make it correspond to u. U is equal to x minus 1. Therefore, 3 in terms of u would be u equals 3 minus 1. So u equals 2 when x equals 3. And u equals 1 when x equals 2. So we'll be integrating from 2 minus 1 to 3 minus 1 for the first integral. So if we integrate that, normally, by adding 1 to the power and dividing by the power, this is what we get. And the integral of 4 is just 4x. And that is still from 2 to 3. So if you substitute the values corresponding to that, then add them up together. That's 55 pi divided by 24 plus 4 pi, which adds to give 151 pi over 24. So this is the volume of the second part of the volume. So the total volume is the sum of the purple part and the green part. So we need to add them together. So the volume is equal to 91 pi over 12 plus 151 pi over 24, which equals 111 pi over 8.